My name is Siddharth and today I'm going to explain about classification of rice grain varieties using deep learning algorithms by comparative analysis. So coming to the contents, these are the things which we are going to go through, and starting off with problem statement. So despite the wide range of rice types available, identifying and categorizing rice grains manually is challenging and prone to errors due to the sheer number and genetic complexity of varieties. Traditional techniques heavily depend on human judgment, which can be subjective and result in classification discrepancies. Consequently, there is an urgent requirement for automated systems capable of precisely classifying rice grain varieties based on their individual traits. So coming to the abstract, this project proposes a deep learning solution for automated rice grain classification using CNNs and RNNs. We collect a diverse image dataset and then we train models and show their superiority over manual methods. This research accelerates rice variety identification and highlights deep learning impact on agriculture. So coming to the dataset, the dataset used in this study was our own dataset. To prepare this dataset, we have collected rice grains from various sources. The dataset comprises a total of 10,000 high-resolution images, and then with each image labeled according to its correspondency of the rice grain. So the names of the dataset, the distinct rice varieties are Akura 1001, Konaram, MQ64 and RNR. Each rice variety is represented by 2000 images in dataset. So prior to the model training, the images underwent pre-processing steps to standardize their dimensions and enhance model performance. Pre-processing techniques include like resizing the images and like bringing back the normalization of pixels, which increases the data diversity. Then comes the data set. You can see the various pictures of the data set looks like this, because there is another thing which is done to this is data augmentation. So data augmentation expands data sets, diversifying examples and mitigating overlifting. Like with 500 collected images, each rice grain subfolder contains again 100 clips. Augmentation is applied per folder due to its limited storage data. And then comes the algorithms used. You can see the algorithms used in this project is CNN. So CNN is a convolutional neural network. It is a class of deep neural networks most commonly applied for analyzing visual imagery. It comprises multiple layers of convolutional filters that extract features from input images. Coming to the second algorithm used is MobileNet. MobileNet is a lightweight convolutional neural network which is designed for efficient deployment on mobile and embedded devices. Then comes the third one, MobileNet V2. It is just an improved version of the original MobileNet architecture. It is introduced to enhance performance while maintaining the efficiency. Then comes the fourth one, which is VGG19. It is a deep convolutional neural network architecture renowned for its simplicity and effectiveness. It consists of 19 layers, including convolutional layers with small 3x3 filters, followed by max pooling layers. And that's it about the VGG19. And then comes the final one, DenseNet. DenseNet is a densely connected convolutional network architecture characterized by its dense connectivity patterns. So after this, we come to the implementation. So in this implementation, we have used comparative analysis So comparative analysis involves evaluating and comparing the performance of different algorithms or models based on the specific metrics or criteria. So in the context of our project, comparative analysis could involve assessing the accuracy, computational efficiency, mobile usage, or other relevant factors of the aforementioned deep learning algorithms such as CNN, MobileNet, MobileNet V2, VGG19 and DenseNet when applied to the task of rice grain variety classification. So these are the factors which we actually measure, the efficiency of an algorithm. Okay, so what were the factors like the accuracy, computational efficiency, memory usage, and yeah, these were the factors which we comprises it. And then comes the Python and deep learning aid farmers in identifying rice types. So images are collected and used to train neural networks. Farmers can photograph the rice grain and our system provides identification. We ensure accessibility and ongoing enhancement. The data is split into 80% training and 20% testing using the train test split. So you can see that the accuracies of the different algorithms, and yes, this is how it happened. Like you can see how the different pictorial representation over here of the algorithms. And then comes the results. So we classified 5 rice varieties with deep learning. Our CNN model achieves high accuracy, but we benchmark it against 5 other models. So out of all this, DenseNet excels in precise grain classification. This enhances crop management and forecasting. Future work may refine our model with new data and advanced techniques. So coming to the conclusion, in summary, our investigation into characterizing the rice grains using CNN algorithms had made significant strides in agriculture technology. Through testing, meticulous dataset curation, and comprehensive statistical analysis, we have achieved remarkable results in accurately classifying rice grain types from image data. That's it from here. Thank you.